We learned the method of integrating factors, and now I'm going to do two problems. One I'm going to do in this video, one I'm going to do in the next video. And these are the exact same equations that we did with when we did variation parameters. And I'm going to show you that I could do it with both methods. So here's the integrating factor method. So here's my differential equation: xy prime minus 2y equals negative x squared. And I'm going to put this into the proper form, which means I have just a plain y prime, and then a function of x times y, and then some other function of x. So p now is going to be, that should be negative, sorry, it should be negative 2 over x, oopsies. And q is equal to negative x, and now we're going to do our integrating factor magic. So the integrating factor, as we learned, is e to the negative p. So it's e to the negative 2 over x dx, which is e to the negative ln x, which is x to the negative 2. And I want you to understand why all of these, if we were in a classroom now, I would explain or make sure that you understand exactly why each of these steps work. So you're gonna make sure you understand every step here. Now that I have the integrating factor, I'm going to multiply by I. So this differential equation here becomes y over x squared minus 2 over x cubed y equals negative 1 over x, because that's what happens when I multiply this equation by 1 over x squared. And now this part here conveniently is y over x squared prime, and that equals negative 1 over x. And that gives me y over x squared equals the integral. I just integrate both sides of negative 1 over x. So y over x squared equals negative ln x plus c. And y, now I just bring the x squared over to the other side, and y equals x squared times negative ln x plus c, which, if you recall, is the exact, precisely same answer we got when we did this problem with using variation parameters. I want to point out one little thing here. If you notice over here, when I integrate here, I have the plus c. When I integrated here to find the I never put in a plus c. The reason is because with I, we're not trying to find a general solution. We just want to find one example of an I that works to accomplish what we want to. We just want to find some function where I can multiply the equation and get this beautiful product rule thing to happen. So I don't need the general solution. I just need one function that works. That's why I don't bother with the plus c over here. But here I want to get the general solution. This is my final answer. I want a general solution. So here I do put in the plus c. Now what I want you to do is to take this solution, put it into the original differential equation, and make sure that it actually works. I want you to check it out until you get that the two sides actually work. Because I could show you a lot of hocus pocus, but I want you to see that when you take this crazy looking solution and put it into the original differential equation, it actually works. This stuff actually works. Okay, see you guys around the block.